In this video, we'll be talking about product rule. So what is product rule? Well, when you have two functions and you want to find the derivative of them, you can't just individually separate them. So let's say you had a function of f of x multiplied by your function g of x, and you wanted to find the derivative of these two functions. You will not, and you cannot, find the derivative of each function individually and then multiply them together. So you find the derivative of f of x and then multiply by the derivative of g of x. This is a no-no. You cannot do this with derivatives. In order to find the derivative of two functions multiplied together, you must use the product rule. So what's the product rule? Well, the derivative of some function, f of x, and g of x multiplied together is equal to f prime of x. So the derivative of f times the derivative of, times just the function of g, not the derivative of the function of g, plus just the function f times the derivative of your function g. And this right here is your product rule. Keep in mind, you cannot just separate them when they're multiplied together. You can, however, separate them if they were added together, right? This works, and you can actually use power rule for that, especially if they are power rulable. But this right here makes sense if you had them separated by a plus, but it would not make sense to separate them if they were separated by a multiplication symbol. So this is good. This right here, plus is good. Even a minus is good. But times, no. So let's do some problems and show you what I mean by this. So let's go ahead and solve this problem using product rule. Now I know that you can combine these to get 3x to the power of 5, right? That's the exponent rules. And you can use power rule to solve this. But the reason why I'm showing you this demonstration is because I'm trying to show you that power rule and product rule all give you the same result even though you separated your formula. So let's go ahead and use product rule here. Product rule was your function derivative of f times your function g plus f times your derivative of g. Right? So let's assign this to f of x and let's assign this to g of x. So let's go ahead and solve for this derivative. So the derivative of f of x is 6x, right? So 6x. G of x is just x to the power of 3 plus f of x, which is just your function, 3x squared. And g prime of x is 3x squared as well. Well, if we simplify all this, we get 6x to the power of 4 plus 9x to the power of 4. If you add these together, you get, well, 6 plus 9 is 15. And you can add these two together because the exponents are the same. So you get 15 to the power of 4. Let's go ahead and just solve for the combination using power rule. 3x to the power of 5 is just, well, you bring the 5 down and you subtract exponent by 1. So you get 15 times x to the power of 4. And these two are the same. So I left the formula written up here for you guys. I just omitted the parenthesis x part for f of x. I just represent it with f and g. So you might be wondering, well, what's the point of using product rule if you can just combine exponents? Well, in the cases where you cannot combine the exponents, you have functions that look like this, where f of x is x in this case, and g of x is ln of x in this case. So for this, we need to use product rule because we cannot algebraically manipulate this or combine anything in any way to make it so that we can use power rule. Let's go ahead and use our product rule here. So we need to find the derivative of f, which is just 1. So the derivative of x is just 1. We rewrite g of x here, so it's just g, no derivative of g, plus f, which is x, plus the derivative of g. So what's the derivative of ln of x? This is just a special identity you need to memorize, but it's just 1 over x. So the derivative of g of x is 1 over x. So if we simplify this, we get ln of x plus, well, since these x's cancel out here, you just get ln of x plus 1 as your derivative for x ln of x. So let's go ahead and solve for this derivative. We'll treat x squared as f of x and sine x as g of x. So we need to find the derivative of f first. So the derivative of f is just 2x using the power rule, and we just leave g of x the same, sine x, plus f, which is x squared, times g of g prime. So the derivative of sine of x is equal to cosine of x. So we have 2x sine x plus x squared cosine of x as our derivative for our function x squared sine x. Now look what we have here. We have a sort of different problem, but we need to apply product rule to two different terms now. So all these are separate functions. So let's treat this as f of x, and let's treat this as f of x, and solve for the derivatives of these two terms individually. So, oops, I accidentally wrote down a dot here. All right, let's find the derivative for this first term first. So let's represent that with red. The derivative for the first term is f prime, which is, using power rule on 3x cubed, is 9x squared. And we just rewrite the function g of x, cosine of x, plus f, which is 3x cubed, and the derivative of cosine is equal to negative sine of x. So we rewrite this with negative sine of x. So I can replace this plus with a minus here. Okay, now that we have the derivative of this first term, what do we do? Well, we need to find the derivative of the next term. So let's treat this as our f, and let's treat this as our g. Let's write the f better. So we need to find the derivative of f 2x, which is just 2. And we need to rewrite g, which is just ln of x, plus f, which is 2x, times g prime. So derivative of ln is just 1 over x. So what we can do here is actually cancel out the x's here, and then we get a derivative of 2 times ln of x plus 2 for our second term. So the derivative of this total function is added together. So we can actually add these two derivatives together to 9x squared cosine of x minus 3x cubed sine of x plus, so we had a plus in between them, so we plus them, plus 2 ln x plus 2 ln x plus 2. And this right here is our total derivative for the function. So we have to use product rule twice here, but we can actually separate them if we see a plus. So keep in mind, you cannot separate derivatives if you see a multiplication symbol between two functions. But if you have two separate functions that are separated with a plus or a minus, or our quote unquote, the math terminology is they're different terms, you can separate them using derivatives. You can separate the functions. So, as always, I need to mention OpenStax since I got quite a bit of inspiration from their practice problems. OpenStax is a free online textbook. Link will be down in the description if you want more practice problems. But, as always, if you found this video helpful, consider subscribing and liking the video. Thanks for watching.